Hey class, it's Mrs. Yan. This video is to support anyone who is trying to work through creating rations with more than 2 ingredients. So, when we feed animals, we are never, or very, very rarely, ever feeding them diets that are as simple as just 2 ingredients. Because while 2 ingredients are awesome for adjusting to a certain nutrient, animals need a lot more than just their calcium considered or just their protein. And so when we make rations for animals in the real world, we're doing that with multiple different ingredients. And a lot of times nutritionists use complex computer programs and research studies to maximize all of the available ingredients in an animal's nutrition. While we're not going to go into the full depth of that process because it literally is a college degree, I do want to give you a little bit of an understanding about how do we look at more than 2 ingredients at a time by looking at how do we create a ration with 3 ingredients. So this is going to give you the perspective on how we do that. Now, Pearson squares are excellent tools, but they are limited. You can only ever do 2 things at a time. So in order to create a ration with more than 2 ingredients, you have to do it piece by piece, one set of 2 at a time. So we're going to start out with an initial scenario that's going to ask us to just balance 2 ingredients, and then we're going to add on in the next step. So our problem on the board says that I would like to create a calcium-rich ration for my calf who has recently been diagnosed with osteoporosis. In order to maximize her intake, I plan to supplement her base diet of oats with added ground limestone. In order to monitor her progress, I will mix 300 pounds of feed to cover 2 weeks of feeding, then reevaluate from there. I'm hoping that a diet at 1% calcium will help to correct the problem. So the very first thing that we need to do is just set up a Pearson square exactly as we have been doing them before. So I'm going to start by getting my box set up. And because I'm shooting for 1% calcium, I'm going to put a 1 in the center of that box. My problem tells me that I want to use oats and I want to use ground limestone. So I'm also going to go ahead and write those down. Okay? So my next step is to go to my feed composition chart and find the percent of calcium for each of those nutrients. So I want to make sure that I'm looking at the right column. It's going to be the CA column on the composition chart. And I want to go down until I find oats, which is in the concentrates and grains section. It's 0.05% calcium. And then I'm going to go down to the supplement section, which is where I find ground limestone, and it's actually 34% calcium. And that's why it's a supplement. It's only in there to help really raise the calcium needs of the animal in this case. Okay, so now that I have that information, I can start working through my problem. I'm going to go ahead and I'm going to put in my arrows, which are going to help guide my map. I apologize, my marker's a little off right now, so it's not writing quite where I want it to. And then I'm going to put my labels on the other side. So on the top, I'm going to have parts oats now instead of percentage of oats. And on the bottom, I'm going to have parts of ground limestone. Okay? So I use those, I start to do my subtraction. As a reminder, your subtraction is going to follow your arrows. So I'm going to take my calculator, and I'm going to take 0.05. I'm going to subtract 0.05. I'm going to take 1 away from that, and that's going to give me a negative 0.95. We always ignore the negatives in Pearson squares because you can't add negative ingredients to a recipe. So I'm going to have 0.95 parts of ground limestone. And I'm going to actually go ahead and erase that and shoot a little bit above the line. As I said, my board is a little bit off right now. So I have 0.95 parts of ground limestone. Then I'm going to do my other math. So I have 34 minus 1, which thankfully is easy math. So I know that's going to give me 33 parts of oats. Okay, so now I know how much of each individual ingredient I need. Now I want to add them up. Okay, so 33 plus 0.95 is going to give me 33.95. Pretty easy to add up that one. I'm going to use my total parts, what I just calculated, to then go ahead and solve out the percentage I need of each ingredient. So I'm going to take that 33 and divide it by 33.95. And that's going to give me 0.972. Remember, we always want to go to 3 places past the decimal. That's going to give us a relatively accurate answer without having to go all of the spaces, which would get a little bit crazy. All right, I'm going to now do my bottom line. So I have my 0.95 divided by 33.95. 0.95 divided by 33.95 is going to give me 0.02, and then it's 79, so I'm going to round that 7 up to an 8, 0.028. All right, at this point, I know what the percentage is going to be of each of these ingredients. So percent of total. Okay, whatever weight I'm trying to figure out for this mix, those are always going to be the numbers that I utilize. In the case of this particular problem, it says that I want to make 300 pounds of feed. So for this specific problem, I'm going to take those 2 decimals and multiply them by 300, and that's going to tell me how much I need of each ingredient to make 300 total pounds. I'm going to take each number, multiply by 300. Now I got to get out my calculator because this is not mental math that Mrs. Yan can handle. Multiply 0.972 by 300, and I get 291.6. And that is going to be pounds of oats. So I'm going to put in my pounds of oats. And then I'm going to take 300 and multiply it by 0.028. And that's going to give me 8.4 pounds of ground limestone. I'm going to abbreviate that GL for the sake of ease. Okay, so I have solved out my first problem. Again, this is exactly what we've been doing the whole darn time. Nothing different. Okay, we've just solved out like normal. It's going to get a little different as we move into stage 2. So, if I skip to our next slide, it says that last week, or a minute ago, I made a 1% calcium mixture of oats and ground limestone in order to help my calf that is suffering from osteoporosis. After a week of feeding, I've noticed that she's having some problems. I talked with my vet and informed me that 1% was too high, and I should instead target a diet of 0.8% calcium. So essentially what I've done is I took a calf who was hypocalcemic, or had low calcium, and that was causing her to develop osteoporosis. And now I've made her hypercalcemic, and I've given her a calcium toxicity. So I need to adjust that feedback down in order to correct that problem before it becomes a long-term health issue. So I've also noticed my calf is having some issues with her feces and probably needs some more fiber. So I decided that I want to add a roughage feed stuff into her diet. It's going to help us lower the calcium, but it's also going to give her some more fiber, which is going to make it easier for her to use the bathroom. So it says that I need to select one appropriate roughage to balance out using our base mixture from last week, or our last problem, as the other ingredient. We currently have 150 pounds remaining, so we want to target making 150 pounds of the new feed. So what do I do here? Okay, it's basically what this problem is telling me is I have this base ration that I already made, and instead of throwing that all out and getting something new, I want to use that, but add something to it that's going to decrease the overall amount of calcium in that feed. So that's going to end up being one of my ingredients then. So my first ingredient that I'm going to use for my second Pearson square is actually the mix that we just made here. Okay, so I'm going to put mix as the top thing on my Pearson square because I'm using that mix, and I know that that mix has 1% calcium. I also know, because my problem told me, that I want to target 0.8 calcium in my new feed. So I need to find something that's going to help balance my mix downwards to 0.8. That means that when I choose a roughage, which is one of the categories on our composition chart, I need to choose a roughage that has less than 0.8% calcium, because one has to be higher, and my mix already is, and now one will need to be lower. There's actually 8 different options I can select. I could use brome grass hay, corn silage, grass hay, grass silage, oat hay, oat silage, Timothy hay, or Timothy silage. Any one of those is going to work perfectly fine. I'm going to go ahead and choose Timothy silage. So I'm going to put a TS for Timothy silage. And Timothy silage, when I look at the composition chart, has 0.5% calcium, which means it's definitely under 0.8, and it will definitely work for my mixture. Okay? So at this point in time, all I have to do for right now is solve out the way that I always solve out a Pearson square. So I'm going to put in my arrows. This leaves a ton of room. Put in my arrows. I'm going to add my labels. So it'll be parts of my mix on the top, and it'll be parts of Timothy silage on the bottom. I'm going to start and do my subtraction. 1 minus 0.8 gives me 0.2. 0.5 minus 0.8 is going to give me a 0.3. I'm really liking this math because it's much easier than usual. So then I'm going to go ahead and add those together to get total parts. So I'm going to have 0.5 total parts in this ration. Okay? So I take those and use those to figure out my percentages. I'm going to take my 0.3 parts of mix and divide by 0.5. I'm going to take my 0.2 parts of Timothy silage and divide by 0.5. And that's going to give me some fabulously short numbers. As I solve that out, I'm going to get a 0.6% for my mixture, and I'm going to do 0.4% for my Timothy silage. Now, the last step in any good Pearson square is to figure out the weights. So that's what I'm going to start with. It says that I want to make 150 pounds of this feed. Okay, so I'm going to multiply both of these numbers by 150. Okay, when I multiply both of those numbers by 150, that means that I'm going to want 90 pounds of my mixture, and I'm going to want 60 pounds of my Timothy silage. So at this point, I've created a feed that has 3 ingredients, because it has the Timothy silage, and then it also has the oats and the ground limestone for my first Pearson square. There is one last step that we want to do, which is figure out of the 90 pounds of mix I have, how much of that is each ingredient. So if I want to figure out my whole recipe, I already know that I have 60 pounds of Timothy silage. I just want to break down that 90 pounds of mix. So I have 90 pounds total, and that mix is made up of, extend our page here, that mix is made up of oats, and it's made up of ground limestone. To figure out how much I need of each, I'm actually going to go back to my first problem. So when we did the first problem, I told you that those percents were how much of the total weight, no matter what that weight was. So I'm actually just going to take these percentages right here, And instead of multiplying them by the 300, I multiplied them by, to make my first mix up, I'm going to instead multiply them by how much of the mix I need in my final product. So I'm going to take that, we'll go back for a second. I'm going to take that 0.972 for oats and that 0.028 for ground limestone and use those as my multipliers. So I take 90 times the 0.972 and I take 90 times 0.028 and that will give me the weight of each of those ingredients in my new 3-ingredient ration. So when I multiply that out, I'm going to have 87.48 pounds of oats. And I'm going to have 2.52 pounds of ground limestone. Okay? So in the 150 pounds I made then, that is the breakdown. 60 pounds of Timothy silage, 87.5 pounds of oats, and about 2.5 pounds of ground limestone. This is how you solve out to create a ration with 3 ingredients. You take 2 of them and do a Pearson square, and then you use that mixture and the next ingredient to add a third and do another Pearson square and solve out. Okay? This is the same process if we wanted to use 4 ingredients. We do a set of 2, a set of the other 2, and then we mix those 2 mixes together. Same process, it's the same concepts that we've already discussed. We're just adding in one last step at the end to break that mixture down. So I want you to try a new problem. So this time, you're going to go ahead to practice, and you're going to use the same base problem. You're going to use this mixture, but instead of using Timothy silage, you're going to go ahead and use, let's use oat silage instead. We use oat silage to solve problem 2. Right now, I encourage you to pause the video, check out how you did, try it out, and then I'll put the answers up in a second of real time, but if you pause, you'll have time to work through. All right, hopefully you paused, hopefully you tried to work back on the problem, scroll back in the video to see it, and now you're ready to see how we solve out. So this time we're going to use oat silage. I need to find that on my sheet. Perfect. All right. So scroll down so we got some more space. So again, my mix was 1%. My sleeves are getting in the way here. Our oat silage is 0.34, which means it is below the 0.8 that we're targeting. So I'm gonna just work through really quickly here, put in my arrows. Parts, mix, parts, oat silage, 0.46 and 0.2. Add those together, 0.66, and divide each of these by 0.66. That's going to give me 0.697 for the mix. It's going to give me 0.303 for the oat silage. I multiply each of those by 150. I'm going to end up with about 101 pounds, nope, about 104 pounds. Say 104.1 0.55 pounds mixed, and I get 45.45 pounds of oat silage. I'm now going to take that 104.55 pounds of mix. I'm going to break it down into my oats and my ground limestone. I multiply by those same numbers, so I'm going to take the 104.55 and I'm going to multiply for oats by that same 0.972 and 0.028. And so that should give me 101.62 pounds of oats and 2.93 pounds of ground limestone, plus the 45.45 pounds of oat silage. Now, if I wanted to double check those, I could add these three numbers together, and if they're about 150, maybe a little more or a little less depending on my rounding, I would know that I should have solved out correctly. So again, this is how you solve out for 3 ingredients. You just do 1 Pearson square with 2, and then your second one, you add the third and use your mixture that you created as your first ingredient, and then you solve out. If you have any questions, please see me in resource or help time. Let me know how I can assist you, but this is what we've been working on in class. So make sure you touch base, work through those problems. Let me know if I can help. All right, good luck, guys. You've got this. Remember, nutrition is important, not just for animals, but also for us. So we need to be mindful about what we're putting in the bodies of our animals and our bodies, because that's going to help maximize what we get out, including thinking through our animal science. All right, bye, guys. Thank you.